Hello, everyone. Wishing you a good morning, good afternoon, or good evening, depending on where you're joining us in the world from today. Welcome to the August edition of the Cloud Foundry CAB Call. We have an exciting time ahead, not just in this call, but also like for the foundation. So a couple of quick updates about activities at the foundation before we jump into the meat of this of the presentation that we have prepared for today. So please be aware that the last dates for CFP submission are a little over a week away. We have about 10 days to go. So if you're interested in submitting a CFP to the Cloud Foundry Day, you have about 10 days to do that. And we all typically tend to do this in the last week, last couple of days, last day, what have you. But we'll send out a few email reminders about this, but be aware that the last date is quickly approaching. There's also a call for volunteers to be part of the program committee. A program committee is a set of 3, maybe 4 individuals who are part of the CF community who get to choose what tracks get chosen for the stage at Cloud Foundry Day. So we have an expression of interest open for those who might want to participate in that. I'm going to leave the link to the form in chat. So if either you are interested in joining this, or if you know folks who might want to be part of this, please share the link with them, or fill in the form yourself. So we're definitely going to need to incentivize this. So we're thinking of a few ways of how to do that. But anyhow, if you're interested in being part of the CFP committee that gets to choose the proposals, then please do fill the form. If you know folks who you think might be a good fit, share it with them. So those are the big updates that I had. So today we have Matt Royal with us. Matt joins us from somewhere exotic on the west coast of the United States. So he's going to talk a little bit about Korifi architecture. So like a lot of you folks already know, Korifi is the Cloud Foundry project that basically aims to build the Cloud Foundry experience to deploy to Kubernetes clusters. We've had many successes in the past few weeks and months. We reached a couple of milestones. So we are at version 0.2 right now, inching our way towards stability and towards production readiness slowly and steadily. But yeah, so obviously architecture and internals are a lot of interest to many folks in the community. And in particular, if you combine like the Cloud Foundry world and the Kubernetes world, it makes for a lot of interesting discussion. So Matt, why don't you kick us off for discussions about Korifi internals?
Can everybody hear me?
Yes.
And I'm in San Francisco, as Ram said. It's a little early for me, so I apologize in advance if I yawn once or twice. So just the structure I had in mind for this is I've got just a deck, just to kind of do a high-level overview of the changes we made and just kind of give us some structure to talk about. And then I'm just going to open the floor for questions and answer any questions that people might have. So let me try to share my screen and see how this works out. Can everybody see that now that it's full screen?
Yep.
Okay, great. Yeah. So I'm here to talk about some recent changes we've made to Karifi. to allow you to plug in alternative workflows for building and running alternative implementations. So for those of you who need a refresher on Karifi or who aren't familiar, it's basically Cloud Foundry on Kubernetes. You might be familiar with CF for K8s. This is the successor to that project, with the idea being that it's meant to be a little more Kubernetes native. So some of the ways it's different is, we're not reusing the Ruby-based cloud controller. We have a re-implementation of the Cloud Foundry API in Golang. We aren't backed by a database. We're using custom resources in the Kubernetes API to represent all of the Cloud Foundry nouns. And it's kind of a bring your own auth situation. So, anything that can auth against the Kubernetes API can auth against Korifi, no UAA anymore. I've got some links here, aren't super useful right now, but when I send this deck out later, when Ram does, so these are some useful resources to kind of understand Karifi and some of the vision behind it. So before I get further into this talk, I just want to put out some caveats. The design we're talking about is still under active development. We're making breaking changes. So the design I show you today may not be the exact design that we have in a week or a month. So just beware that breaking changes are likely to come, but this will at least give you an idea of what we have in place right now. Yeah, so originally Karifi directly managed both building and running of apps. Now we did that we used KPAC images to do the building, and we use stateful sets to do the running, right? So you build your image with the KPAC image, we make the droplet out of that, and then we run your app instances with stateful sets. The work we're talking about today added this new abstraction, these new abstractions rather, the build workload, and formerly known as the run workload, but now called the app workload. And these are just resources that include all the information you need to implement either of those workflows, building your image from source or running an already built image. And then they're kind of an attachment point where you can plug in an implementation that maybe does something a little different. Just some quick terminology. The components that actually do the building, I'm going to call builders. The components that do the running, I'm going to call runners. Pretty straightforward, right? And as I mentioned, they both use these workload resources to as their interface and to communicate state. Now, one thing that's worth knowing is after we introduce this, the behavior in Karifi is actually still the same. We've just taken the existing behavior that was part of Karifi core and put them into these sort of sub projects. There's a KPAC image builder, which does what it sounds like, and the stateful set runner, which also does what it sounds like. Now, the goals of this work were to basically to make it possible to plug in different behavior, right? And we wanted to minimize the difficulty of doing that and make it as simple as possible, right? So that's the rationale behind putting all the information in one resource and using that kind of exclusively for communication between Karifi and these alternative implementations. Also, we wanted to create a very clear separation between Karifi and these so that we didn't have to know the details of the underlying architecture for how you're building your image, how you're running it. This is somewhere where we still have some room for improvement, but we're actively working on it. And in the short term, we only intend to have, on a given deployment, to have one component that's actively doing the building, one component that's actively doing the running. In the future, we may add support for having multiple concurrent builders and runners where you dynamically dispatch to one or the other. So here's, there's a lot of words. Here's a diagram to help break it down. So this is kind of a simplified flow of what the internals of Karifi, like the objects on the K8s cluster and the components involved are doing when you create a build now. So as I mentioned, we use custom resources for all of our nouns inside of Karifi. So we've got the CF build, the creation of that by the API indicates, hey, we've got this build we want to run. It turns out that a lot of information goes into generating a build. So the controller part of Karifi correlates all the information that's necessary from the build itself, from the package. You'll get the source location, for example, from that. Any credentials that need to be in there from service bindings, et cetera, et cetera. And then it's going to bundle all that information up, put it on the build workload. And then in the default deployment, you've got this KPAC image builder that I mentioned before, which is going to take the information on that and ultimately build a KPAC image from it. Now, what this diagram doesn't show, but it kind of follows from this, is as the KPAC image either succeeds building or fails for some reason, that state will be communicated back to Korifi by updating the status of the build workload here. And there's a very, very similar diagram for what the app workload flow looks like. Just the trigger is a little different. So instead of creating an app being the trigger, it's setting the desired state of the app to running. But the same thing happens. It correlates data from a bunch of different sources, puts it onto this app workload object, which then triggers the stateful set runner. And then that creates a stateful set. And the number of available replicas or running replicas rather, is communicated back through the workload object. I've got some more links for, again, to be useful after this talk, but one thing that might be worth looking at right now is just what these actually look like in practice. I don't think it's worth going through all the keys necessarily, but we can just do a quick overview. You can see that for the build workload, you've got information about all the environment variables that need to be available in the same format you would have on, for example, a pod container in Kubernetes. You've got information about where to actually pull the source and the credentials you need to do it. And then the status of the result gets communicated back here, right? So this was a successful build, and so it succeeded. And you have the information about where to pull the image actually from. Under droplet here, and also what processes are on it and which commands to run. So this might look familiar from CF for VMs, just kind of in a more Katesy format. And similarly for the app workload, we have we actually have probably more information than we need on the app workload. We're likely going to cut a lot of these fields off soon, but it's the same idea. And then the implementer of the runner or the builder is responsible for taking this input and deciding how that's going to actually be represented on, for example, your stateful set. Yeah, so I went through a lot pretty fast. How about, I don't know, does anyone have any questions? Anything you want me to dig into deeper? I'll also stop sharing my screen, potentially.
Hi, quick question. What triggered this redesign? What was the impetus to come up with this type of style?
Yeah, I think right now it's mostly a proof of concept. As I mentioned, we're deploying all of our applications as stateful sets right now. But there is talk of potentially supporting deployments or maybe even Knative services in the future. And so part of the motivation for this design was enabling that work to be simplified in the future. So you can imagine that if we do want to support deployments, we can write an alternative runner that just has the logic around deployments and decide not to deploy with the stateful set runner. And we've pretty cheaply supported a different workflow without a lot of engineering work. So that was part of the thought process. Actually, I have some other team members here as well, Phil and Tim. So if either of you want to chime in about motivation, please do. Oh, and Giuseppe, sorry. Giuseppe.
To remember the vision document, I think that we had, I think even before starting the implementation, and one of the goals of this new project was to make specific functionalities pluggable, both so that this could be useful to as many for as many use cases as possible, but also to avoid like re-implementing stuff. So one thing we decided is, authentication, we delegate that. Networking, we work against well-known interfaces instead of providing our own implementation. And so I think it was only natural to do the same for runtime, for building. I can't remember if there were other interfaces that we haven't covered, but yeah, I think the main ones were networking, runtime, building, auth. So yeah, this means Korifi can build with all sorts of backends and can run stuff with all sorts of backends.
Are you integrating with things like Bazel and other type of builders behind the scenes and then integrated it back in? Is that what you're trying to accomplish?
So when we talk about a builder, is mostly a beast that is capable of going from sources to Docker container. So I don't know if Bazel qualifies, but mostly
you can do that in Bazel, yes.
Yeah, so I guess someone could implement a builder based on that then. Or like just more simply, for example, at the moment we don't support Docker files, but like another builder could just build based on Docker file. Or, there might be many use cases. Support for, I don't know, at the moment we support specific build packs like cloud native build packs. Who knows, tomorrow and something new comes out that is interesting or better, we can just plug it in. The hope is that if the abstractions are well designed, we'll be able to do this.
Okay. Thank you.
It's worth mentioning something that didn't make it into the slides is that Giuseppe and some of our other European teammates have recently added task support, and it uses a very similar structure. It uses a task workload, which I didn't talk about today because I haven't dealt with it much, but just so you're aware that's there.
The default implementation uses jobs. So again, same spirit, like the default implementation uses Kubernetes built-ins, tries to be as cheap and straightforward as possible. And lots of this is at least inspired by the previous Irini implementation. So we've basically replaced the Irini types with these new types that are a bit more, I would say, straightforward to use, a little bit cleaner, removed some craft in the process, and managed to also get rid of our dependency in the process.
Yeah, so when I mentioned earlier that we're likely going to print a fair number of fields off of the app workload, part of that is that we basically just started by copying the exact same structure as the Irini LRP, and we've realized that we don't need some of those fields. All right, well, if anybody else thinks of a question or wants to kind of engage with the team, you can find us on the Cloud Foundry Slack in the Karifi dev channel.
Thanks, Matt. We can probably get the slides out to folks as well. So I'll follow up with you on that. But in general, thanks for the talk. It was really useful. And I think the more we talk about these architectures and some Korifi primitives, the better it will be for people who are trying to build an understanding about the project. So yeah, thanks. And yeah, thank you everybody for being on the CAB call today. Hope to see you on future editions too. And to everyone watching the recording, stay tuned. We'll be adding content all the time. Thanks very much. Bye-bye.
Thanks.